Welcome back. Welcome back, everyone. We are starting our afternoon lecture, Programming Basics Week 1, Day 3. We are going to go over 3 topics today: operators, functions, and parameters. Now, I moved the operators portion of this morning's lecture to this afternoon because functions and parameters, they go together. So really only 2 topics this morning: operators and functions that come with parameters. Okay, so well, they don't always come with parameters, but they go together. Okay, so let's divide our lecture into 2 to 3 parts. All right, so we have learned about for loops. We've learned about if statements. We've learned about variables and how to create arrays. Now what we want to do is pivot for a little bit and talk about an operator. Okay, let's talk about what operators are and how they are to be understood and how they work. So let's look at our platform, and then we'll switch over to functions. And then at the end of the lecture, I'll tie in how this is all going to be relevant to what we've learned so far. Okay, so let's start with operators. What are operators? The first operator I want us to learn is the modulo operator, which you can do some reading on and remind yourself what the platform says here on the operator section, and then you go to modulo. All right, so I'm getting this information from here, but let's take a look at the board and do some modulo operations. Okay, so modulo operator. Okay, so if you look at your keyboard, that symbol above 5, if you press shift above the 5, you should see this symbol. This symbol here is the modulo operator. This is the modulo operator. Really useful tool. The way we can use this is by understanding division first, and that this is looking for a remainder number after you do a division. So let's test our math skills. What is 2 divided by 2?
1.
2 goes into 2 once. Nice. And after it divides into 2, what is the remainder?
0.
0.
Exactly, because it divides 2 divides into 2 evenly. It divides into 2 perfectly. So 2 modulo 2. Oh my gosh. Let's see. Can I erase? Yes. Okay. 2 modulo 2 equals 0. That's because 2 goes perfectly into 2, and there is no remainder after you've done the division. So the modulo operator is asking, what's the remainder after you've done the division? What's the remainder after you've done the division? Okay. Let's do another one. Okay, so let's do, come on, there we go. 3 divided by 2. So this 3 divided by 2 is what? 1, right? 2 goes in. Sorry, go ahead.
No, go ahead.
Yep, 2 goes into 3 once, right? With a remainder of 1. So 3 modulo 2. Oops, that looks like a 3. Let's erase. I'm enjoying this new erase feature that I've been able to master. Okay, 3 modulo 2 is 1. The reason is 2 goes into 3 once with a remainder of 1. Okay, so the modulo operator is looking for the remainder after a division. So how can we use this modulo operator to our advantage? Now that we know we can find remainders of numbers, how can we use this modulo operator to our advantage? Let's take a look. But before we see how we can use it to our advantage, let's take a quick poll. Do we understand that the modulo operator is looking for the remainder? Looking for the remainder. It's not doing division by itself necessarily. It's looking for the remainder. Okay, so let's do another example. We're not done with this yet. I just wanted to see how well we understood just that concept. So let's create a for loop. So we're still working on modulo. Let's create a for loop for var I equals 0. Let's start at 0. And while I is less than 5, let's increase I by 1, I plus plus. Okay. So we've created our for loop. And we're going to write an if statement within our for loop now. We're going to write an if statement within our for loop. Let's see how we do this. So we're going to write an if statement. And we're going to use the modulo operator to check for even numbers. So how can we do that? How can we do that? We're going to use the modulo operator to check for even numbers.
Would it be I modular 2, or like if it doesn't equal 0?
Okay.
Or
really close, really close. So close that I'll use that as an example later on, but we're going to do this. We're looking for even numbers. So we're going to say if I
if it equals 0, then it's
exactly. If I modulo 2 is equal to, remember we need that double equal sign to ask the question, is it equal to? If you use 1, you're assigning it and you're breaking it. So that's not going to work. You need a question. If I modulo 2 is equal to 0. If after you divide I by 2 and you get a remainder of 0, what does that mean?
That is even.
That it's an even number, right? Because if 2 divides into any number evenly, we know that that's an even number. Because any number divided by 2 without any remainder is an even number, like I just said. Okay, so let's console log something. We'll say console log even num. Right, and let's see if we can t-diagram this if we have any space left. We'll do it 1 at the top right. Var and then val. And where are we going to put our console? Let's try to shove it down here. Okay. So var I equals 0. So let's write that in. I start with 0. We enter. We check here. If I modulo 2 is equal to 0, can 2 divide into 0 evenly without any remainder? 0 is one of those numbers, right?
It's 0, but
okay. So this one, I don't believe will log. Well, I'm going to assume that this one's not going to log. We'll test it after. If I'm wrong, then I'll bear the shame. All right. So this one here is not going to pass. So it's going to increase I. All right. So I plus plus. Now I is 1. If I is less than 5, we enter. Now then we check again. If I modulo 2 is equal to 0, I, which is currently 1, is modulo 2 is not going to be equal to 0 because 1 divided by 2 is not going to have a remainder of 0. The first one is going to be 2. So we know that this is not going to pass. We got to increase, and we increase to 2. Now,
Why doesn't 0 pass?
I'm pretty sure 0 wouldn't pass. I could be wrong on that one. Let me double check that after I
Okay.
scribble
Oh,
this.
okay.
So I'm just going to double check that after we're going to run this code. All right. So 0, 1, 2. And so now if I is less than 5, so 2 is less than 5. All right. So we pass. So we enter the for loop. And so now we check if I modulo 2 is equal to 0. I is currently 2. 2 divides into 2 evenly. And we know that that's going to give us a remainder of 0. So we enter here. Now we console log even num. So let's go ahead and write that. Even num. That's our first console log. Okay, now we increase I after we've done this. We exit this if, we go into the for, and then we increase. Now, I is 3. So is 3 less than 5? Yes. We go into the if statement. Is 3 modulo 2 equal to 0? No. 3 modulo 2 is equal to what?
1.
1. So this is not a true statement. And then we go ahead and move along. So then we increase I again. Here we are at 4. 4 is less than 5. So then we check the if statement. All right. 4 modulo 2 is going to be 0 because 2 goes into 4 twice. Nice and even. All right. So then we console log even num again. All right. And then we increase I again. We have to increase until we cannot pass this requirement anymore. All right. So we've done this. I is not less than 5. We've finished. Let's double check my answer. I want to make sure that I modulo 2 when it's 0.
Well, the thing is, I think even if it's because like 0 is not an even number, but there's nothing left over.
Right. Yes. But if you ever try in a calculator 0 divided by 2, what do you get?
Undefined.
Yes. So it's not going to be 0.
Well, you can, if it's 2 divided by 0, that's undefined.
Yeah. So I'm
But
pretty
0
sure.
divided by 2 is 0. Okay.
Yeah. Yeah. Let's double check it just so that we can see the visual.
I'm interested.
All right. So we have a 4.
Hey, Josh, I looked it up. 0 is an even number.
Yes.
And 0 modulo 2 is 0.
Okay.
I had to look it up. I didn't know.
Yeah.
All right. Okay.
Yeah, the other way around is undefined.
Okay. Sometimes I just write these off the top of my head. I don't test them before. So I hate to learn while I'm doing a lecture, but if I'm glad that we all know at the same time. So var I equals 0. I, while it's less than 5, we're going to increase I plus plus. That is super helpful to know. Okay. So now we write an if statement. If I modulo 2 is equal to 0, console.log even num. All right, so I have my for loop. I have my if statement that has that modulo. And let's look for that console log. And in order to know what I currently is, every time I see this console log, I'm going to show you guys what you can do here. You can add a comma after your string, and you can add a variable. A variable, if you want to call it, cannot be in quotes because you're just calling the variable itself. And so we're going to see even num printed every time I modulo 2 is equal to 0, and then we're going to see I. So we're most likely going to see I here as the first console log. So let's see. Okay. Here we go. There we are. When I is 0, it's going to look here. Is I less than 5? Yes, because I is 0. So then we continue. And then it checks here. I modulo 2. 0 modulo 2, is it equal to 0? We're going to find out. It's yes, right? Yes. There we are. We've entered this. So this has passed. We have entered. Now we know I modulo 2 when it's 0. 0 modulo 2 is 0. Okay, so thank you for that, Tyler. And let's make a note of that, everyone, that it wasn't correct on my writing there, but now we know. All right, so let's continue. And then we check again after we've increased I to 1. Let's keep going. Is 1 modulo 2 equal to 0? It isn't, right? Because we know that 1 divided by 2 is not going to have a remainder of 0. So then we increase I again. I is now 2, as you can see here, 2. 2 is going to be less than 5. It's going to also pass our if statement with the modulo symbol. We have our even number. Okay, we increase to 3. And then 3 didn't pass, so let's go to 4. 4 is less than 5, so this will pass this. We'll enter the for loop. Now that we're inside the for loop, we're checking the if statement. I being 4 modulo 2 is going to be 0, right? Because 4 is an even number. And we get that even number, and then it's going to console log I. Now that we've seen these 3 console logs, we've increased I one last time. And this will no longer qualify, so we're finished with our loop. And that's it. Okay, let's do one more modification, and then we'll close this out with a poll. So this is a really brief introduction to modulo. And now I've changed it to not equal 0. So what is this going to find? If I modulo 2 is not equal to 0. So what am I looking for here?
Odd numbers.
Yeah, right? Because if it's not even, it's odd. So logically, it's going to be odd, but we know that if it's not equal to 0, that means it's not an even number. So if 2 does not divide, if 2 divides into this number and it's not 0, we're going to find an odd number. Let's check this out. Okay, so here we are. I modulo 2, we have it starting with 0, and 0 didn't console log. So we know that it's working. And when we increase to 1, this is going to pass. And then we're checking our if statement now when I is 1. So 1 modulo 2, if it's not equal to 0, is it going to console log now? Is it going to go to the next line? What do you guys think?
That's a tough one too, because
If it's not equal to 0, right? Because what is 1 divided by 2? So this is a tough one. I want to see what you guys think before we move on. Put your answer in the chat. I want to see, does it go or does it not? I think I know the answer.
I don't think it goes.
I don't think it's an odd number, but I think I logged it as an odd number. Let's see. What is 1 divided by 2? It should be 0.5.
Yeah, that's what I'm saying. It's like a float.
So how about this? Let's log not an even number. That would be better, but let's continue. Odd number. So we have our odd number. Even though it's 0.5, we'll have to change this to be exact when starting at 0. Okay. All right, so we're continuing, and we got all of our even numbers logged that are less than 5, 1 and 3. All right, so I want to do one more thing before we continue. So let's take a poll check before I do anything else, though. How well do we understand how the modulo symbol is working, how it finds the remainder after a division? Okay. So I think what we need to do to make this actually work is to say if I modulo 2 is equal to 1. That's one way to work around it, right? Because when I is 1, 1 divided by 2, now it's still going to log odd num. So here's the workaround. What we need to do is say, we're going to wrap this if statement here. We're going to wrap this one in another if statement. So let's wrap this in a if statement saying, if I is not equal to 0. If I is not equal to 0, then check the modulo operator. So now that I've opened this up, I want to paste this one inside this one, because this is, we're only going to check to see if it's even or odd. If I is not equal to 0, and we also had a problem with 1 as well, right? So we want to count for 1. So let's go ahead and introduce one more thing here. All right, I'll emphasize this a little bit later on, but we can get familiar with what this does. This is not something on the test, but this is something that's just going to help us here right now. Okay, this is a double ampersand, double and sign. This is also called an AND gate, which is it's going to work like this. We're going to check to see if I is not equal to 1. Or if I is not equal to 1. There we go. So both of these statements have to be true. For this double and sign, the statement on the left has to be true, and the one on the right has to be true in order for it to enter in. Okay, so if I is not equal to 0, and if I is not equal to 1, well, actually, this would not work, because as soon as I is 0,
It's not gonna go.
this would not be true either. So this here is a double and sign, which means both have to be true. If you want at least one to be true,
So or
yes, we use an OR gate,
double
which
pipe.
is this double bar symbol. Double bar symbol. Okay, now let's test it, and then we'll move on after this, I promise. Okay. All right. Here we are. I is 0. If I is not equal to 0. Oh, okay. I see what I did wrong. Okay. This is going to enter. This is going to enter. Yeah. Okay. So we don't want it to enter. So how can I fix my code to make this not enter when it's 0 or 1? I don't want this to check if it's 0 or 1. So what do I need to change in order to fix this? I made a mistake. So who can help me fix this? I entered here when I didn't want to check to see if it was even or odd yet.
An else if.
The
It's It's right here. I'll give you guys the answer. It's this here. I said not equal to 0. I wanted to only check
If it's equal to 0 or 1.
exactly. If it's equal to 0 or 1, then it will enter, but that will still enter. So we don't want it to be that either. Now I'm getting tripped up. So let me just take a minute to pause. What do we need to fix? If I is equal to 0, then we want to check it. So that's right. So if I is not equal to 0, then we do the check. So that's correct. Or
So yeah, you should change it back to
the AND gate, right?
Yeah.
I think I got a little ahead of myself. Yeah. All right, let's test it now and then we'll move on. Okay, here we are. The if statement is going to check if I is not equal to 0. Right now, I is 0. So is this going to pass? No, see, it went straight to increasing I, so that's good. Increase I to 1, we want it to do the same thing. Not even check. There we go, we got it working. So now it's going to increase to 2. 2 is less than 5. And then now we enter because I is not 0 or 1. Now we can check to see if this number is even or odd without having to worry about dividing into 0 or 1. So that's the way to do it. Okay. So we have our odd number 3. And that's the only odd number we get out of 5 because we don't reach 5. And that's all we have, right? So that's the modulo symbol. I never had to get myself out of a knot like that, realizing that dividing by 0 or 1 would be illegal. But now we know, okay? There won't be any problems this hard on the test, but we're looking here at the modulo symbol. This is what we're wanting to understand. All right, so last pull for the modulo, and then we'll move on. Okay. Okay, we have a few other operators. These are really useful operators. I want us to all figure these out, and we can do this together. So let's take a look. Math.round. We know that, oops, that's not what I wanted. Oh, I figured out what I did to make it go to accessibility. Okay, but I don't know how to undo it.
You try hit escape. I think that normally works.
No, it's when I press function and then K.
Yeah.
Okay, at least I know what I did. So now I know how to avoid it. Okay, so that's good. All right, let's look at numbers real quick. All right, I'm just gonna write numbers 1 through 9. 5, 6, 7, 8, 9. All right. This is how we round numbers in case you forgot. 5 and above rounds up to 10. 4 and below rounds up to, or round would be rounded down to 0, right? So 5 is the dividing mark that goes up to 10, or then 4 would be going down to 0. So let's I just wanted to remind us how rounding works. I'm sure we all know, but let's look at this here. Var num1 equals math.round 2.5. So if we round a decimal number, that 0.5 is going to round up, right? We said it goes up at 5. Let me increase the font. I don't want to strain you guys' eyes here. Okay, so 2.5 is going to round up to 3, right? Because 2.5, that 0.5 is going to round up to the nearest 10th, which is going to be making it go, make this 2 go to a 3. So 2.5 rounds up to 3. If you use math.round on 2.4, this num2 that holds this math round would then have the value of 2, because 2.4 would round down. And so we also have math.round negative 2.9. So what would 9 round to? Since this is a negative number, this would round to negative 3. So we're still looking at this decimal number, 0.9. That's going to go up to 3. So we have a negative. So we have a negative 3. 0.1 is going to go down. So we have a negative 2. And that's how rounding works. We have to call the math library math, and then we are accessing the round feature of the math library. And then we have to write in the parentheses the number we're going to round. Right. Okay, so the next math operator I want us to look at is floor. Floor. How does floor work? It's different than round. What it does is it brings to the floor, imagine it would round down any number. So if this is 0.5, if it was math.round, it would go up. But since this is math.floor, we're going to bring it down to 2. That would be the number it rounds to. Okay, math.floor would round to 2. Math.floor 2.4 goes to 2 as well. Doesn't matter how high it is. If it was 2.9, it would go down to 2. That's what floor does, brings that decimal portion of the digit down to the floor. All right, and for a negative number, how does floor work on a negative number? Negative 2.9 is going to go down, right? Because negative 3 is less than negative 2.9, so it's going to bring it down to the floor, negative 3, and negative 2.1. It's still going to bring it down to negative 3. Doesn't matter if it's 0.9 or 0.1, anywhere in between, math.floor is going to bring it down. Okay, and the opposite is true for seal. 2.5 go up to 3. 2.4 goes up to 3. Negative 2.9 now goes up to 2 because, negative 2, because negative 2 is a higher number than negative 2.9. So it's going to the ceiling. It's going up. So negative 2 is above negative 2.9. And so it is also with this one here. Okay, so we're bringing this to the ceiling, negative 2. We're bringing negative 2.1 to its ceiling, so that is negative 2. And lastly, we're going to go over math.trunc, this one here. Math.trunc just completely cuts off the decimal point ending, and it leaves it as a whole number without what was previously there as a decimal. So just like you're cutting off a tree trunk with an axe, all right? So you're cutting off the decimal point ending. Now 2.5 becomes 2, 2.4 becomes 2, negative 2.9 becomes negative 2. We're just cutting off that decimal end. And negative 2.1, same thing, negative 2. We're just cutting off that ending. Okay, so there are 4 inbuilt functions. Keep these in mind. We're going to be using these next week in some of our challenges. Okay, so just have these in your notes somewhere. All right, so let's take a poll on how we understood these inbuilt math operators. Awesome. Thank you guys for being so focused. I know I make mistakes from time to time, but you guys are pretty engaged, so you guys are able to learn through it. All right. Now, we're going to get to the heart of the lesson. All right, the meat and potatoes, as they say. We're going to go over functions and parameters. Functions and parameters. And I'm super excited to give you guys this lesson, not because it's so much fun, exciting, but it was so difficult, or it felt like it took me a long time to really grasp this functions and parameters part of programming JavaScript. That I had to really, make it easy for myself, simple for myself. So that's what I want to do for you guys. I want you guys to not struggle with this as much as I had to. So functions and parameters. Let's go to the platform that deals with this, and then we'll start drawing on the screen. So we'll go here to functions and parameters, this part of the platform that's below operators. Let me decrease the font. And here we are. Functions. Okay, so let's talk about functions a little bit. Up to this point, we've been writing variables, we've been writing for loops, we've been writing if statements, and we've been writing them bare. Okay, we've been writing them without any sort of wrapper or context. We've just been writing them and making our code run by sticking them in our code runner. We either in that export function main area or in our Python runner, we just, stick it in here, right? So that's totally fine. When we run our code, this will read right away and just start working on this right away. This will just immediately pick up, all right, you have an if statement from the very beginning, so I'm going to start dealing with this if statement. Now I have an error in my code, but that's not the point. The point is, we need to wrap our code in now what we're going to define as a function. What is a function? A function, I want us to think of a function as a tiny little microwave, okay, microwave machine. All right, we're going to put our code inside of our microwave to get it started. We need to create a start button though, okay? So we're going to put our code in here to be executed, but just because it reads that this is a function doesn't mean that it runs it right away, as you would see this if statement just run as soon as it is detected. So this function is going to be able to help us divide our code into separate functions. What if we have a program that has a bunch of if statements and for loops, and we want them to run at their appropriate time, not just all at once? Well, the way we would do that is to divide the code into functions and have those parts of the code run when they're supposed to. So I want us to think of this as, I just call it a microwave because I'm thinking of a machine that you can put something into, right? So you can put something into a microwave and it has a start button. So that's an easy analogy for me to use. So let's write a function and define how it should be written. So functions. Okay. All right. And what we notice, I got a little ahead of myself. What we notice first is that there is this keyword function. So we need to write that keyword function, just like we wrote a keyword for the if and for loop. We need to have that function keyword, and then following it, the name of our function. So let's get those steps down. Okay, here we are. Functions. Okay. We write the keyword function, that lets our computer know that we are writing a function with that keyword. Now we need a name for our function. We need a name for our function. So let's think of a name. I want my function to be called say hello, because that's all I need it to do. All I want my function to do is to say hello. So let's give it a name. My function name is going to be say hello. All right, that's the name. And anytime we create a function, after we've written the name, we have to have these parentheses area. This parentheses area. Now, I'll explain what this is for in a little bit, but for now, we know that we just have to have this here, or else this function is not written properly. Okay, this has a purpose, but we don't need to know it yet. After we've done this, let's open up the curly brackets and close them. So this is our function. In this area here, anytime we see these brackets, that means that's an indicator to us that this is like the area where we're going to define for the computer to do something. We want this to do something. So I'll just name it the do something section. Just as always, okay? When these curly brackets are here, that means we're related to this function, we are going to do something. So let's just console log. Let's just console log hello. Console log hello. So now we have a function, and its only job is to console log. Its only job is to console log. So what I'm going to do now is I'm just going to take this function and I'm going to write it in trace and see what we get. Okay. So let's go ahead and do that. All right, function. Say hello. Remember, we use camel casing, which means the second or all the words following the first have their first letter capitalized. Now we've opened up the function, and here's where we want to do something. So we'll write the string hello in the console log. Okay, so we have our function. Let's go ahead and run it. So what should we expect to see now? Any guesses? Am I tricking you guys?
Nothing.
I was about to say, I don't think I knew.
All right, so what happened actually was nothing at all, and that's expected. Why is that expected? Well, what's going on here is that this function is read, it's understood by the computer. Okay, I see that you have a function called say hello, and it's supposed to console log hello, but where's my console? This thing is already finished. If I press the play button, that's it. The reason is this function needs a start button. What we've done so far is equivalent to put the food in the microwave, close the door, and walk away. So it exists, everything is there ready for it to start, but it's not going to start unless someone tells it to. So let's create the start button. All right. The way that we invoke a function, this is called function invocation. All right. The way we invoke a function is by picking up its name. So we write its name, the name of the function, say hello, and then we write the parentheses there. This here, this is our start button. To our microwave. Okay. The function won't actually do anything inside unless it sees this somewhere. Unless it sees this somewhere, the function will not do what it's supposed to do. The computer will acknowledge, okay, I see you have a function, but I'm not going to do anything with it unless you tell me, unless Simon says to start, right? And the way we can make it do that is by writing its name and the parentheses. You need the parentheses as well. So now let's run this. Okay. And here we are. And now we've hit it. So let's rewind a little bit. Do you see how when the code runner is reading, very beginning, it goes straight to line 10. It doesn't even highlight any of these lines. It's already stored this in its memory. It doesn't need to start it at all. It needs to just start it as soon as it finishes executing this line. So as soon as it executed this line, it said, okay, you want me to start this function? I'll go ahead and start it. So now it's highlighting this one. Well, it entered this one already, and then it went straight to the console. Okay, it went straight to the console, and as soon as it passes this line, we have our console. Hello. Here it is. All right. Here's the time. We're gonna take a poll check. We're gonna take a few more today. All right. So I want to make sure that we're understanding that how to write a function and how to make it start, and that a function won't work unless we have that invocation, that start button. Okay, we'll go over this a couple more times to make sure it clicks. Okay, so let's give another analogy. All right, this is a recipe in a cookbook. A recipe doesn't cook itself. We have to start the process. This is starting the process. All right, when you see this, that means cook. All right, cook the recipe. All right, what's the recipe? And then it reads it, and then it does it. And until it reads that line that calls its name in the function, it doesn't do anything. What's another analogy? Think something like the Harry Potter books, right? This is the spell in the spell book. All right. Spell won't say itself. It needs somebody to do it. This is the waving of the wand, right? This here is going to make the spell come out of the page. This is going to make invoke the function. That's a technical term. This is going to invoke the function. All right. And however many times I invoke the function is however many times the function is going to run. So let's go say hello again. Now we'll see that the function will run twice. And we should get now 2 console logs of hello. So we called the function's name twice. The first time it's read, now it's going to that console. We get the first console log. So we finished the first invocation. Now it goes to this invocation, this start button. So we start it again. So let's go start the function again. And then we console log hello, since that's what our function does. 2 function calls, 2 console logs, right? 1 console log per function call, and then it did this. And then it read line 12, function call, then it console logged again. I want to see if it makes a little bit more sense now that I explained it this way. Okay, give me an honest answer. I don't care if you're not understanding. We'll get you to understand. I just want honest feedback here. This is an anonymous poll, by the way. I'm sure you guys know that now. I mean, I see, but you guys can't see each other's. Okay, so This is a function call. However many times we call the function is however many times the function is going to run. Now, let's talk about this parentheses. Let's pivot back to the Blackboard real quick. Okay. So now we're going to move on to parameters. Parameters. Here we go. Spelling was one of the most difficult subjects for me. It still is. So I'm always like doubting myself. All right, parameters. Let's write a function. Function. I'm going to make it the same function. All right, we've got to write the name. Hello. Okay. And so now in this parentheses area, I'm going to open it up a little wider so that we can write something in it. I'm going to create the function. Okay, console.log. Okay, all right, so I'm leaving these empty on purpose. We're going to fill them in just a minute. I need to call the name of the function in order to get it started. So I don't want to just create the function, I want to call it as well. So let's call this function. I'm just deciding what color to. Okay, let's do this. No, I'm not going to write now. Say hello. Okay. Pen's breaking down. What I'll do is I'll just continue this on in trace because I don't want to deal with this. So let's move along to trace. I'm just going to, all I'm going to do now this is what I was going to write. Okay, so we have here a clean slate. What we want to now do is change its greeting based on the function call. All right, so let's have a placeholder right here. Okay, so this placeholder, this is where the parameter is going to go. This is the parameter. And I'm going to say, I'm going to call it greeting. And I'm going to console log greeting. All right, let's run this. And I want us to see that this is going to not work. This is going to break, right? And I want to show you why. This here is a placeholder. This greeting here is a placeholder for anything that it would receive. All right, so it's holding its hand out for like a baton. Think of like a relay race. Someone give me a value for greeting, and I'll pass it along to this console log. And once it's passed along to this console log will greet something. But if no one passes anything to this one here, if this is just having its hand open, waiting to receive a value to give it to its console log within the function. But if we don't give it this one a value, it's not going to run. So I'm just going to show us a bug, and then I'll show us what we need to do to pass some values into those parameters. Okay, it's undefined. It's undefined. We console logged in undefined because we're just waiting to receive a value, and we're waiting to pass it on as well, but we didn't get a value to begin with. So how do we give it a value? We have to pass in what's called an argument. An argument is something that passes information onto the parameter, and that parameter then passes it to wherever it's called. Okay, you can console log whatever you're given here. You can use it to loop through, you can divide it, add it, whatever you want to do to it, cut up to pieces. We want to just give it a value so that it can do something with it in the function. So let's give this one a greeting. We'll say the first greeting, we'll just keep it to hello. So now what's happening is that this function call, remember this function won't run unless this is invoked. But now there's something slightly different. We're giving this value hello. We're giving it to greeting. This greeting is then passing it to this console log. So what we're doing in the very end is we're passing this hello all the way down to this greeting. So it's going from here to here, then here to here, and then we should see it in our console. So let's see that in action. Okay. So we have here now in our T diagram, greeting has a value, and its value is hello. That value is going to get passed now from here to here. And that's now why we see this console log. So now it's no longer undefined. Hello got passed into this greeting. The greeting then can be used anywhere inside the function, however many times you have now access to that hello. Let's run a poll check, and then I'll do a couple more variations of this. And this way we can reuse the function and make it have different greetings based on the function call. We can reuse code this way. Let me give an example. So the first greeting we'll say is hello. Remember, we can make more than one invocation. So the next greeting, we'll just make it howdy. What about howdy since I'm in Texas? All right, so say hello. And first invocation, we're going to make it console log hello. And then we're going to run this function again with the howdy. All right, so let's run it. Okay, here we go. First one is hello. Did you see that? It highlighted it. That means, okay, I see you want to press the start button and you're starting it with a hello. Okay, so I'll pass this along to this greeting here, which passes along to this console log here. Now we have a value. Greeting is going to be hello. So we should see that console log hello. There we go. We finished this function call. We've done say hello with hello. Now that we finished this, it's going to read the rest of the code and see this next call. Let's run this one. There we go. We see it. Okay, you want me to run the function again now with the word howdy. Okay. So then it passes it along to greeting. Greeting receives it and gives it to console log again. And there we go. We have both here now consoled at the bottom. So we can reuse a function now, and we can pass in different arguments to what's called the parameters. Okay, and let's look at parameters in our platform. Let's run this one. Before we run this, let's take another poll check. Just want to make sure we're all reasonably following behind.
So greeting is just a variable.
Is
Is that right?
Greeting, yes. What it is, it's a parameter.
Parameter, okay.
Yeah, it's a parameter. So think of it like a relay race. It's not the first person in the relay race. It's somewhere in the middle, right? So this would be the first person in the relay race, passes the baton to this one. All right, now this runner in the relay race the runner's responsibility is to receive and pass, receive and pass. So receives what is given in the argument here, argument given to parameter. Now this parameter gives it to wherever it's called in the function. Okay, let's do a little bit of something different. All right, so I'm going to make this one called add numbers. Add numbers. And now I'm going to pass in two numbers, X and Y. And I want you to console log X plus Y. All right. So this function, if I don't invoke it with an invocation, it's not going to run. And since it has parameters, I need to pass in some arguments. Right. So let's write our first invocation, add numbers. And let's do 2, 2. All right. They're going to get passed in the order. They're going to be received in the order that we see the parameters listed here. So the first one is going to be given to X. The second one is going to be given to Y. So we want to see now add numbers to 2 plus 2. And before I do that, let's just do it. Let's run it. Change it up later. Okay. So we want to see this add 2 plus 2. We're giving 2 to X and 2 to Y. So here it's just acknowledge the invocation. It says, okay, you have 2 arguments you're going to pass in, 2 and 2. This must go to the 2 parameters that are available in the function call. So it reads it now. X is 2, Y is 2. Do you see that in our T diagram right here? Right here. Var val. Okay. And so let's keep going. Now in our terminal, I wish they made this bigger. I'm going to complain so that they do that. But here we see 4. Okay, 4. That's because we passed in 2 to X, we passed in 2 to Y, and now anywhere in our function, we can access X and Y. We can now add them together if we'd like. So let's do another function call. We'll keep this one. We won't delete it. Let's just add another pair of numbers.
Josh, when you're adding the numbers in the bottom to invoke the function, it doesn't have to be within the curly brackets, right? That's just because you're using trace.
It does have to be in. Oh, are you talking about this here?
Yeah.
So yes, this is just unique to trace. And that's why I struggled with this week teaching through trace, because I don't want you guys to pull this into your assignments. I just need to put my code inside this one. But as you can see here, this is another function, right? This is a function. And this one has the same function syntax, except for now it says export. So we don't know how this function is called somewhere else. But it's called when we press run. So let's just for the sake of eliminating that, let's see it on a different view. There we are. Okay, so here's function add numbers. We have X and Y. So this is going to add X and Y no matter what we give it, right? So the first time we give it 2 and 2, the second time we give it 4 and 8. So let's see it now. All right, so you see here add numbers. All right, so we want to do this first. It doesn't even put an arrow to the function. It just acknowledges, okay, you're there, but we're not gonna deal with you until we see that you've been called. So here we're calling it 2 and 2. And so there it is. X is 2, Y is 2. So we're going to console log X plus Y. There we are. We get 4 there. Now we go to the next function call. 4 gets passed into X and 8 gets passed into Y because this is the order that we see X and Y in our parameters here. So it's going to receive it in the order that we're calling it in our function. 4 and 8. So next, return value undefined X plus Y. Okay, this is something for another day, the return value. We want to just see X plus Y for now. So we get that 12. All right. Now I want to do one last poll while I consider if we should end this now or if we should save something for this. No, I think we got to extend the lecture just a little bit longer. There's one more thing I want us to know. Okay, this is what I want to show you guys. Function returns. Function return. So far, we've been using console log. We've been using console log to see any values that we want printed to the console. At this point, we're probably going to get a little confused at first, but that's okay. It's natural. So let's create our function. Function. Let's say why not just keep it to something we've already done? Let's just make it return hello. Okay, this is our function, return hello. Right? So we are going to make a function without parameters. We don't need to make this one have parameters. I just want to show you what a return does. A return, we have to call this function, so let's do the invocation. Return hello. And now we'll say return and then we'll put here hello. So we know this hello here, this is just a string, right? This is completely familiar to us. We know this is a string. The only difference we're seeing now, the only thing different is this return right here. So what does this return do? Can anyone tell me? Anyone have a good definition they want to share?
Is this for like answering stuff, like kind of like text adventures type things?
I'm not sure what you mean by that. Text.
Like responding to messages?
Well, I'm not sure what you mean by that answer. I think you may be onto something, but I would have to see what you mean specifically. So let me just give a definition for this one. All right. So what the return does is it gives the value of whatever's following it.
Yes.
So right now, whatever's following this return is this string hello. So we're going to give this, let's see, is there an orange color? Yeah, orange is good. So, or this string hello, we're actually going to assign it. Now, whenever we see a return, it does two things. One, it exits the function, right? Exit function. So as soon as we hit this return, no matter what we're doing in the function, we're done with the function. If at any point we hit this return where we have then wrapped up whatever we're doing in the function, even if there's lots of code left that we hadn't read through or done anything, we know the first thing return is going to do is exit the function. The second thing it does is it gives value to function. So it gives value. It gives value. So this string now gives a value to this function. Okay, what does that mean? What does that mean? It gives a value. So whenever we t-diagram something, right? When we run across a variable or a value, we write the variable, for example, x. If we found an x and we found a value to be 5, we would do something like that, right? We have a variable on the left and a value on the right. What this return does is it would give a value to this function, just like our variables have values. So now we can write somewhere on our t-diagram something like this. Return hello. Okay, that's our function. And now it has a value. The value is hello.
It's like a default parameter because it has none, right?
Parameter is not the technical term, but yes, I can see that you understand it. I see that you're getting it. Whatever it's doing, it's not console logging, so we're not printing anything to the special screen area. We're not necessarily printing anything. We're giving a value to this function. We're giving a value to this function. So we can see here the function name is return hello, and it has a value. The value is going to be whatever it returns. So if we had a var x equals 5 somewhere written right here, and we returned x here, what would this return hello be right here? 5, right? So whatever we return, right after we return, we give it that value to the function. This in particular, understanding returns is going to take a little bit of tinkering. You're going to need to tinker with it to fully grasp it, to get that aha moment. So let me do a quick version of this, and then we'll wrap up the lecture. So say hello, and then we're gonna return hello, and we're gonna call the function say hello, and we need the parentheses whenever we call it. I just want us to see now what would happen if we ran this function as is, just like this. Okay, let's run it. Okay. All right, what happened? We saw the function invoked, we saw it run, but then we didn't see anything in our t-diagram and we didn't see anything in our terminal pop up, right? Why is that? That's because we didn't ask for any of that. All we did was return a string to this function. We didn't ask for a console log, so we're not supposed to see anything in our console. We didn't ask for anything other than just this return. So this has a value and it's hello. If we want to see the value, if we want to see this value printed to the console, this is what we'll have to do. We'll have to put this function call in a console log. So console.log. Let's put this function call in a console log and see what we get now. Okay. All right, so we've just console logged this function call. So it runs the function as soon as it sees that, okay, you want me to console log this? All right, what is this? Oh, I have to run this? Oh, I see. Okay, so it runs the function. It returns hello to this function. And now this function is going to have a value. So when we console log this function, we're console logging this function's value. And that's why we see now hello in the terminal. Like I said, this is going to take some tinkering. You're going to have to write this out yourself and then just make slight changes every so often to see how it works with different conditions. I know I'm going over time here, but let me show you one last thing. All right. So if I delete this hello, right, I just have a return. Now, what do we expect to see? Any guesses while it's running? If we delete that string after the return, we return an undefined, right? Because this function doesn't have a value unless the return gives it a value. The return didn't return anything. It just exited the function because it had nothing following it. All right, so you're going to have to build some functions, call the functions, pass in some parameters, and see what the difference is between what a console log is and what a return. A return gives a value to the function. A console log is just in order to print to this area here. Okay, so let's take one last poll for the day. I want to see how well we understood that last concept. Okay, if you're not at a 10 yet, what you need to do is have a little practice. You can even take what I've written, you can check it out in the lecture, rewrite it on your own trace. You know, when I say tinker, I want you to, okay, what would happen if I put hi in here? Okay, but what would happen if I deleted the console log? You're only going to understand and see the differences if you test it yourself and see your own testings. Okay, not just mine. You have to test it yourself. Okay, and that's about it, guys. That's our lessons for today. We've gone over operators, functions, parameters. We've gone over a function return, and now you guys have some assignments to solidify this knowledge. So the best way to solidify some knowledge that you've just received is to put it into some practice. So the sooner you put it into practice, the better. So we have these code challenges for you: predict functions, code challenge return, code challenge debug, and code challenge parameters. So we can see these here. All these code challenges are practice and optional assignments. So if you're falling behind on assignments, don't, stop what you're doing to do this, but these here are going to help you practice today's lesson. All right, and what we have what we want to finish by the end of the day is that code challenge parameters. So even though it is a practice assignment, we want to make it a goal to be able to do this by the end of the day. All right, this one is an extremely helpful activity. Highly recommend you guys do this one, at least this one. And so, all right, where are we now? We finished this assignment. We we finished pretty much day 3. The rest of the day, we're going to take time to work on our assignments, get that end of the day challenge done. We have some homework, which is to read up and through belt tips and strategies. So tomorrow, we have one more lesson on for loops. And then we have that time to study, catch up on assignments, get ready for our afternoon belt exam. Okay, so one more lesson on for loops. It's just going to be additional information to what we learned already today in for loops. Not a huge difference, but we're going to now iterate through arrays tomorrow. Okay, so that's what we're going to do different than for loops today. today in for loops, we just asked to, increase a number. If it's less than a certain number, then loop this many times. Now we're going to loop through an array tomorrow morning. Okay, and that should wrap up all that we need to know to be able to pass our belt exam. Okay, so just as a reminder, it's 7. You need to predict 7 of the outputs, and 3 of the questions you'll need to write the code by hand. You'll need an 8 out of 10 to pass. Okay, so you'll need to write at least 1 question, write it out by hand if you had finished all the other ones and you got 7 out of 7 on the predict. You need to at least do 1 challenge where you write by hand. Okay, so that ends today. Does anyone have any questions about what we're doing? Functions, parameters. Anyone feel frustrated, like they need a little bit more time to understand this? You feel free to drop by my room. We'll do it like additional practice. So don't be shy. That's what I'm here for. I'm here for you guys. Okay. So drop by my room and we'll do some more practice if we need. Okay. So, all right. Good luck on your challenges today. Looking forward to you guys all passing the exam tomorrow, right? We're so excited. We're not nervous. No. All right. Sounds good. All right. So let's stop this recording.